Welcome to Leica Step-by-Step Guide for Archicad. Create a 3D model from point cloud data in less than 30 minutes. Learn from a real-world case to create 3D model of an attic using point cloud data from Leica 3D Scanner. The 3D scanner captures millions of data points with high precision, providing an accurate representation of the existing structure and condition. This level of detail is challenging to achieve with manual measurements. The powerful Leica 3D scanners utilize laser beams to capture detailed and precise 3D data of any structure. What used to take hours or even days with traditional methods can now be accomplished in a fraction of the time. The point cloud data provides accurate, detailed 3D representations of existing conditions. In this step-by-step guide, you will learn how to work with point cloud data in Leica software. And finally, we create a real 3D model of an attic in Archicad using point cloud. You can also get a free access to the point cloud data and create your own 3D model. And now let's take a closer look with our expert Karen at how to edit a point cloud and create a 3D model in less than 30 minutes. First, you have to upload the data and create a project.
Welcome, my name is Karen Hughes. Today I will be showing you how to prep your point cloud data so it is ready to create a 3D model. Once the data is collected in the field and downloaded, it is ready to be imported into Cyclone REGISTER 360. Launch the program and create a new project. Drag and drop the data into the import area. The RTC 360 data is already pre-aligned because of the Viz technology used on board the scanner. On the right-hand side, the only import option that is important to select is Import Images. Click Import. Once the data is imported, it is important to check the link errors and the alignment of the point cloud. Select the bundle in the Explorer panel and review the link errors in the Properties panel on the right-hand side. The values look great. Next, it is important to check the alignment of the point cloud in the True Slicer menu. In this example, the data is already orientated nicely along the length of the building, making it easy to check the horizontal and vertical views. If the data is on an angle, users can select a setup and hold down the shift to rotate the bundle to a good orientation. This can also be achieved by setting a UCS, which will be covered in the next section. True Slicer displays the point cloud in colors by setup, so it is easy to see the overlap. Select the bundle and select True Slicer from the flyout menu in the graphical view. The slice thickness and location controls at the bottom can be adjusted to see a plan view of the project area. If all the colors line up, then the alignment is good. Next, we will check the alignment along the X or Y axes. Using the Slice tool, we can scroll through the point cloud and check the vertical alignment. If needed, the orientation of the point cloud can be adjusted using the advanced UCS tools. The best tool for orientating a point cloud along a particular axis is to use the biplane method. Navigate to the bundle cloud and zoom into a surface you want to use for orientating the X or Y axes. Launch the UCS tool, select the Biplane method, select Set Y or X by plane at the bottom, then draw a fence on the surface and double-click inside the selected area. An arrow will display the direction of the X or Y axis. You can click once on the surface to change the direction of that axis. Click Create. Click Top View and View All to see the new UCS orientation. The UCS is saved and you can always go back to the original world point cloud orientation. Clean out all the people, let's use the handy Smooth Surface tool. This tool isolates planar surfaces, making it possible to delete anything above it. In this case, starting with the point cloud in top view, turn on the Smooth Surface tool and the point cloud will turn gray. Double-click on a clean portion of the floor to run the Smooth Surface tool. Points above the floor will turn red. Continue to double-click on red portions of the floor until the floor is completely gray. Anything in red can be erased using the fence tool. Anything colored gray will remain. It is helpful sometimes to start in ortho mode. Draw a fence around the red noise and click Delete Inside. Switch out of ortho mode and zoom into different areas. Create a fence and delete inside to remove the noise. Repeat this procedure until the floor area is completely clean. Click on the Smooth Surface tool to finalize the process. To complete the cleaning process, let's use the limit box to create a vertical slice through the point cloud. Open the Limit Box Manager and turn on the visibility of the box. Raise the top up slightly and adjust the front side to hide the wall. To access the back portion of the box, hold down the Shift key. Move the rear wall closer to create a vertical section through the attic. Turn off the visibility of the point cloud, zoom in and use the fence tool to remove any noise. Turn back on the visibility of the limit box and adjust the limit box again by raising the bottom up to remove the floor. Turn off the visibility of the limit box, rotate it to top view, and use the fence tools to eliminate any remaining noise. Once the noise is deleted, deactivate the limit box to show the entire point cloud. The point cloud is clean and is now ready for modeling. In this example, let's publish an E57 and RCP. Click the Publish Options tab and select E57 as one file. It will open a window to save the file. Navigate to where you want to save it, name it, and click Save. Then click beside RCP Cloud. It will open a window to save the file. Navigate to where you want to save it, create a folder and open it, name the file, and click Save. Click Publish. Once the files are published, check the folder to see the results.
And now we'll show you how to create a 3D model of the attic in Archicad using a point cloud in a quick run-through. Our point cloud is ready for modeling, and we now want to upload it to Archicad and create a 3D model of the attic. First, we need to import the point cloud. In our case, we select File, then Interoperability, and then Import Point Clouds. After that, select the desired point cloud in the Explorer. In the next window, select the action, Create in Place. Then we select the level we want to assign the point cloud to it. Now we have to create an additional section in order to know at what level the bottom mark of the point cloud is located. This information helps to create an additional floor, which will be the floor of our point cloud. If the cloud has more than one floor, this way you will know how many additional floors you need to create and what the distance between them will be. You can find out the distance using the Measure tool or the hotkey M. Object selection settings on the plan. Floor plan and section. With the help of Floor Plan Display function, we can set which part of the cloud we want to see when viewing the floor plan. This function makes it easier to work while building the model on the plan. Creating a section in the point cloud. With this function, we can hide part of the model for comfortable work or for viewing individual elements. Using the slab tool, we roughly outline the point cloud on the plan. For more detailed adjustments, you need to use the 3D Explorer. Placing walls and columns. Using the instrument walls, we place walls according to the point cloud on the plan. When creating walls, it's recommended to use 3D view because often walls have a slight slope, niches, or holes. First of all, when selecting the Roof tool, we place the axis, which will set the direction for the geometry of our roof. In the settings of the roof itself, you can also change the degree of its slope. Assigning a separate layer for the point cloud makes it possible to hide the cloud at any moment of work for a better understanding of the placement of some elements of the model. Using the skylight tool, choose the one that best suits the program and place it on the roof surface. Then adjust the dimensions using the point cloud. To trim walls or any other element of the roof, follow this path, design/solid element operations. Do not touch the window that appears, but select those elements in the scene that we need to trim to the roof. Once selected, click Add as Target. After that, select the roof, which should trim the previously selected elements, and click Add as Operator. Then select the desired operation in Choose Operation and press Execute. This tool can be used to cut and clean all elements. Thank you for watching. And now download our sample point cloud now and give it a try for yourself.